In this video, we'll be looking at one-sided limits. First, let's look at the limit from the right. The limit from the right, shown this way, the limit as x approaches c from the positive side of f of x, is the y value as x approaches c from values greater than c. So in other words, we're going to approach c from the right side. So if we were asked to find the limit of the square root of x as x approaches 0 from the positive side, we're going to come in on the function and we're going to ask ourselves, what y value do we get closer and closer to? So we can see that the y value is 0. In this example, we're asked to find the limit of the square root of 4 minus x squared as x approaches negative 2 from the positive side. So we're going to approach negative 2 on the function. And we want to know what y value we're getting closer to. So this one is a limit of 0. The limit from the left, shown this way, the limit as x approaches c from the negative side of f of x, is the y value as x approaches c from values less than c. So we'll be approaching c from the left side. Here we're asked to find the limit as x approaches 0 from the negative side of the greatest integer function, x. Now we know that that graph is a step function. We're approaching x equals 0, so we're getting closer and closer here to 0, but we're on the function. So if we stay on the function and approach x equals 0, we can see that the value of this limit is negative 1. Now, if we look at this limit as x approaches 0 from the positive direction, we're staying on the function, but this time we're approaching 0 from the positive direction. And we can see that that limit is 0. Because remember, you're looking for the y value. So as I approach from the negative direction, I have a limit of negative 1. On the same function, as I approach 0 from the positive direction, I have 0. This leads us to a theorem. Since these two values are not the same, negative 1 and 0, the theorem, when the limit from the left is not equal to the limit from the right, then the limit, or the two-sided limit, does not exist. So our theorem says the limit as x approaches c of f of x is equal to L if and only if the limit as we approach c from the left is equal to L and the limit as we approach c from the right is also equal to L.